Hello, YouTube. Welcome to my channel, The Morgile. Been doing a lot of flat Earth videos here, and a lot of people have been asking me to, sort of introduce myself on my channel. So I guess it's been sort of a long time coming, but I'm just sort of lazy in that way. I don't think me personally has anything to do with the flat Earth debate, but you know, you guys want to know me, so here I am. Just going to mention a couple of things real quick. First of all, this whole path has been very enlightening, very freeing. I know there's a lot of people who think that I'm crazy or that you're crazy if you subscribe to or at least consider the flat Earth model, but you know, there's just a ton of evidence that proves it. A ton of evidence that disproves the globe Earth model. And so, it's just safe to conclude with 100% certainty that we definitely do not live on a globe. I know there's a lot of argument against this because of the programming that we've all been sort of trained to execute since we were just little kids. A couple of things that I've always found very, strange or unacceptable or sort of a mystery, even as a child. I mean, for many years of my life. And I've mentioned some of this stuff on my videos, but just giving you sort of rundown. I mean, I guess that's what I'm doing here. It's a channel preview, so. But for my whole life, I never really understood how the constellations would always remain fixed in their alignments. Now, if you think about it, the Big Bang model asserts that all of the different galaxies and stars are expanding at extreme speeds in all different directions, constantly getting further and further away. The universe is supposedly expanding. And so all of the stars within those galaxies are sort of bound to their respective galaxy, but the galaxies themselves are always getting further and further away. I never really understood my whole life, and I thought about it a lot, and I could never quite figure it out. How was it possible for the constellations to remain fixed in their alignment forever? You'd think that if we were, spinning around the sun, spinning around the galactic center of the universe, which is hurling through space over 1 million, I've heard up to 2 million, somewhere in there, 1 million something miles an hour, in this direction, and the other galaxies are going this way, all different directions, and yet year after year, decade after decade, century after century, millennia after millennia, I mean eons, the celestial bodies have remained fixed in their alignment, which it always has been a problem for me. As long as I can remember thinking about astronomy, it never made sense, but like I've said before, I couldn't put my finger on it. Never really could figure out what's wrong with that. Well, there's all sorts wrong with that. Um, I'll just touch on the Jeranism effect for a minute, which I've spoken of before in my videos. Jeranism is a flat earther. His channel name is Jeranism. But if you could think of, just to give you a couple of household items here, just to make it easy. So here's the sun. Here's the Earth on its tilt going around the sun like this, right? So that's the way the Earth goes in 6 months. Okay, so if the daytime is always towards the sun, so this is daytime, that's nighttime, okay? When you come around 6 months, then this is going to be daytime, and that way is going to be nighttime. So the Earth's spinning the whole time, but no matter what, day is always facing towards the sun, and night is always facing away from the sun. So let's say this is summer, and there's daytime for this side, daytime for that side. Now you got nighttime here. Nighttime, let's say it's summer, is way over here. So the stars above head should be millions of light years in that direction. Okay? Or actually, since we're at a tilt, it should be more like down in that way. Okay? Now, when we spin around the sun, and to say the other time of year, summer, and we're still got the same tilt, then the stars that we see overhead should be millions of light years over that way. And by the way, spring would be up towards the camera and fall would be back towards me. And simply put, we always see the same stars, predictably in patterns, at any time of year, on some place in the world. The stars don't behave like this. There's just simply no way you could see any of the same stars during the summertime as you can during the winter, or same thing with winter and autumn and spring, or none. They're all mutually exclusive because space is an arbitrary direction, or at least visible space from the Earth. Nighttime is always away from the sun, so we're talking, nighttime is that way during the winter, nighttime is that way during the spring, nighttime is that way during the summer, and it's this way during the fall. And for some reason, the North Star Polaris stays fixed above our North Pole the entire time and is visible every night. Okay, so that's a major problem. This proves that the heliocentric model is wrong, and there's no possible way that we can be spinning around the sun. And people don't like to believe it. They think that I'm somehow lying or making this up. But anybody can go and verify this. And I think a point to make on this is that the sun isn't obscuring all of those stars. You see, the sun is just making it daytime, and you simply can't study the stars during the daytime. So, just to summarize it, stars visible overhead during the summer, all of those stars, none of those stars should be visible during the winter, period. Game, set, match for heliocentric model. Okay. One thing I like to touch on a lot is, in terms of gravity, is the North Pole star Polaris maintaining fixed in its alignment above our North Pole during all seasons, during all years, during all eons. If that star was so distant, our wobbly axis, according to the precessional, the axial precession causing the precession of the equinoxes, should give us a new North Star every 50 or 100 years at the most. But the North Star stays pretty well fixed directly above our axis, which would be theoretically impossible in the heliocentric model, where our sun, our Earth is spinning around on a wobbly axis, spinning around the sun at an angle, with the sun spinning around the galactic center. And yet, for thousands of years, we can predict the patterns of the stars, and we can see all the stars during all seasons. This doesn't make any sense. The heliocentric model has been thoroughly debunked. Now, all of this, except for one point, which is the Earth being a globe, it all relies on that for sure. The one point that all of this relies on is gravity. And gravity is supposed to be this, well, really what it is, it's an imaginary force that was dreamed up by theoretical physicists who were trying to explain the observations of astronomers. So, and even the original proponents of the theory of gravity even, asserted that their whole theory and even the theory of the spinning Earth was nonsensical, impossible, almost asinine, but it was one way to explain the observations of, astronomers throughout history. But one force that we've got to have in order for all this to work is gravity. And gravity's been thoroughly disproven. I have put it in a couple of my videos. But, okay, so if I'm at the equator and I weigh 175 pounds, you have to understand, if I'm at the equator, I'm standing perpendicular to the axis of the Earth, spinning over 1,000 miles per hour, and any object spinning in nature is going to generate an outward thrust to objects connected to it. It's called the centrifugal force. That outward thrust generated by a spinning body has nothing to do with rotations per minute. It has strictly to do with speed. Now, of course, there is a relationship between rotations per minute and speed. However, let me give you an example. If you look at the gravitron, which I can probably cut that in here, I do have it in one of my other videos, but gravitron is a ride at the fair where there's, it just basically, it's a ride that spins. And there's an engineer of the ride sitting dead in the center, or like on top of the bullseye at the dartboard. It's a circular ride, obviously, and then the ride goers stand around the outside edge of the ride, and as the thing starts to spin, the ride goers are pushed, up against the wall, and as it goes faster and faster, they get pushed up against the wall that they actually start to slide up, with their backs against the wall, and they can actually like lay sideways on the wall. It's because of the centrifugal force, which is caused by all objects found in nature that spin. Now, one thing you'll notice about the Gravitron is that the engineer of the ride is spinning at the exact number of rotations per minute as all the other ride goers. And so, for some reason, he is not compelled to be stuck to the walls, yet the people standing farther away from the axis are indeed compelled to be stuck to the walls. So think about that for a minute and keep that thought, keep that in the back of your mind. Now, in terms of rotations per minute, it really doesn't make a difference, but in a sense, it really does make a difference if we're talking about larger and larger bodies. So I'll give you an example. If you had a Gravitron, let's say it spun twice as slow or half the speed. So we've got the Gravitron that spins half the speed, but the radius from the center is twice as far. So let's just think about that for a minute. The people towards the outside would experience a similar outward thrust to the ones on the smaller, faster ride. Agreed. I mean, it might be more or less. I'm not going to get into the calculations of the force, but it would be similar. They'd be compelled to be pushed against the outside. However, the gentleman in the center would be spinning, even more slowly and standing on top of the parallel with the axis. So the disparity between the outward thrust that he feels there in the center would be even greater in the slower, larger ride, because he's spinning even slower, yet standing in the same position above the axis. Okay, so if we can, let's just take this a step further, and let's say that we've got a Gravitron ride that spins only 3 times per minute, so very slowly. It'd be barely spinning at all. It wouldn't be, if you spin something around 3 times per minute, that's pretty damn slow, okay? It would be 3 times the speed of the second hand on the clock. So, if you're standing in the center of that ride, you're going to be spinning 3 times faster than the clock. You're not going to feel anything but maybe a little bit dizzy. Okay, and you're certainly not going to be compelled towards the outside edge, right? Even if you walked several paces away from the center, you still wouldn't be compelled towards the outside edge because there's not enough force generated by that speed. Now, again, it doesn't have anything to do with rotations per motion. It has to do only with speed. Now, the people on the outside edge of this ride, let's say it's a radius of 100 miles or a diameter of 200 miles. If we want to get the circumference, we'll just simply multiply pi times 200. Pi is 3.14 and then some, but we'll just say 3.14 times 200. It's 628. Okay, so that's the circumference. But it does 628 3 times in a minute, so let's multiply that by 3. So it's going 1884 miles per minute, and then we got to multiply that by 60. That's 113,040 miles per hour. Okay, so again, now that's people standing all the way to the outside edge of a Gravitron that's only spinning 3 times per minute with a 100-mile radius or a 200-mile diameter. Right. So now, first of all, think about this. The man standing towards the center is barely going to be spinning. He's parallel with the axis, so he's not going to experience any outward thrust whatsoever. If you travel towards the outside of the ride, going 113,000 miles per hour, you're going to experience some serious outward thrust, or G-forces. It's going to be overwhelming. But let's just say, hypothetically, you're able to crawl over the outside edge of the ride and hang on to it for dear life on the outside. You'll be spinning